As we come across or examine an experiment, we want to be able to summarize the possible outcomes and the likelihoods of those outcomes of said experiment. And so we turn to the probability distribution, and in some sense we can think of this as just the listing or the very much related to the frequency distributions, or the frequency tables that we built in earlier chapters. Here we're listing out the probability distributions to summarize and to keep track of all of the possible likelihoods that might arise of the outcomes that we're interested in. And so we'll look at this first in a table, and then graphically, how do we visualize that? We'll go over a variety of different examples as we make our way through the videos, but let's start with a fairly simple case. Now, in lecture, we briefly talked about the case of flipping 3 coins, and here we're going to just talk about the simple roll of a dice. And so in this case, and we'll consider a 6-sided die just for sake of time here. And so a 6-sided die has we end up with a actually pretty unique probability distribution in that it's consistent, or it's even across it. So let's just talk about the roll of the probability distribution with a single roll. Now, we only have one process happening. We're only rolling one die, and so when we think about the number of possible results, we can use our calculation from chapter 5, but it's simply 6, right? We have 6 possible results, and so our results. And we'll see that this is a little unique because, as we'll quickly see, we have 6 results, and these each correspond to a single outcome, right? And we're curious about the sum of the die, and so if we list them in the same order, all right, this would be a roll of a 1, a 2, and so on. And so there is no doubling up or repeated results here, which is, again, somewhat it's not a commonplace. So when we transition this to the summary table or into our probability distribution, it ends up looking about the same. So as we take this information and we try to build a frequency, or sorry, I keep slipping back to our earlier terminology. When we build our probability distribution, we would say something like the sum. And I'm keeping this general because we might want to think about more than one die roll. And so the sum of 1, 2, 3, 4, 5, 6. Now, each of these is only related to one result, right? So this, on the left here, we're outlining all the possible results. It just so happens in this nice clean form that each result is only related to one outcome. Yeah, so again, maybe not that abnormal, because if you think about, winners of a horse race, if we list all the horses, that's all the possible winners that we could have. Yeah, so then lastly, so we have 6 results, and we want to know the probability of the outcome, right? So each of these, ran out of space there, but the probability of the outcome, each of these has only one result, which satisfies the condition of that outcome having been the outcome of the event, and the experiment. And so what we have here is each of these corresponding to a 1 in 6 probability. Okay, nothing earth-shattering here. We probably are aware of each of these having a likelihood of 1/6, but here we have now a probability distribution, and we would graphically depict that as such, right? So we have 1, 2, and each of these is going to have the same height. And so we'll come back to this, a very similar result, and this is closely related to the idea of a uniform distribution. And so we'll see that in the next chapter, and it feels very similar to this, in that no matter or all of the possible outcomes have the same likelihood. Okay, it'll be a little different because we'll be in continuous random variable world, but has some kind of unique results to it. So here we have now a probability distribution and the visualization of that, or the graphical presentation of it for a single die roll. So pretty straightforward. Let's turn and see that it becomes a little more complicated with a 2 die roll. Okay, so if we want to instead roll 2 dice, let me see if this will flip over. Okay, so if we're talking about 2 die or 2 dice, then things become a little more complicated, right? So thinking back to chapter 5, we have then 6 times 6, and so we have 36 different results that could occur. And so we could list those all out, again, following the same kind of process. Result 1, 2, 3, and so on. We would get, there'd be 17. We keep going down here, there's 36. Okay, and so if we wanted to start outlining those, again, let's imagine that we are really interested in the sum of the 2 dice. Okay, so the order in which these dice come up is not important. Now, if we want to write them all out, we will want to kind of do this in some organized fashion. But we'd have a 1 and a 2. Could have a 1 and a 1, a 1 and a 2, and the sum would change depending on this. Now, as we go through, something that's different than our previous, in our 1 die situation, the sums were unique to each result. Here, of course, at some point down here, we would have a 2 and a 1, which would equal 3 on the outcome, right? And continuing on, we'd see more and more repetitions, right? 2 and 2, pretty rounded dice there, and so on, and until we get to the bottom, and we'd have a 6 and a 6 with a result of, or a sum of 12, an outcome of 12. Okay, so the key point here is, let me just fill in one more. So there's a 3 and a 1 somewhere along the list. This is not exhaustive. There's more results in there, but the key here is that there are repetitions within this, right? So there's a couple 3s, there'd be 3 4s. Okay, and so each outcome is no longer independent or unique to a specific result. So when we turn and summarize this, just like we did with the last one, we're not going to have the same one-to-one relationship. And so if we want to list out the possible sums and the probabilities, the probability of outcome, here again we are listing the possible outcomes. So that ranges from 2, 3, 4, all the way to 12. And we'll skip over some of this. And so now when we go to the probability of outcome, we do actually have to count these up. Now, you can see already with just rolling 2 dice, we have 36. If we want to talk about rolling 5 dice or something like that, or more complicated scenarios, we probably are going to want to quickly start to learn some mathematical techniques to shortcut this, and so we'll learn a few of those as we go. But for with only 36 results, we could physically count these up, and we probably can just logic through them as well. So there's only one way to get a 2. There's actually only one way to get a 12. And as we saw, there's 2 ways: a 2 and a 1 and a 1 and a 2 gets you to a 3. There's 3 here, and so on. And in fact, it becomes this kind of stepwise function. Somewhere in here, there's a 7, which maxes at a 6. And so, yeah, so now we have a way to list out all of the possible sums and the probability of outcome. Now, I've made a little error here. The probability of outcome is not 1, 2, 3, 4, 5. It's 1/36, right? So there are 36 results, one of which will give you a 2. 2 of those will give you a 3, and so on. So these are all divided by 36. Obviously, some of these can be simplified, but so you have a 1 in 6 chance of rolling a 7 and getting to move the robber in Catan. So again, we can turn and visualize this, put this on a graph. Okay, let me do that quick. And it would, again, stretching from 2, so on, and now it's not going to be straight across the board. We're going to have this kind of step function, and 12, and so at each level here, there's a unique. That's not 6, 136, right? And same thing on the 12, and we're going to step up. Okay, so typically draw those kind of like a bar chart. So 2 out of 36, and so on until we get to the height of 1/6, which I'm drawing this at a different scale, right? So on the previous one with 1 die, each of them had a 1/6, so they would all be up here at the 7. In this, well, that's not drawn well to scale at all either. So let's redo that, and so on. So it looks something like this if I had better ability to draw. Okay, so we have this type of a flow, and again, for those of you that play dice games or Catan or Risk or something, you probably have some type of a model of this, hopefully, otherwise you may lose quite a bit, built this kind of model in your head as to what's more or less likely. But here we can see the math and actually calculate those specific probabilities. Yeah, so next we'll turn and talk about how do we take the mean and how do we take the variance or standard deviation of these probability distributions as well, as a way to summarize what's likely and kind of where the results typically fall.